Well, hello, Algebra 2 class. How are you doing? Hopefully you enjoyed your spring break. And speaking of breaks,
No one has ever escaped from Alcatraz.
I may have found a way out of here. You looking at something?
but what could we possibly be escaping from? Notice we're doing nth roots. We're simplifying radicals. Yes, ladies and gentlemen, it is time for radical jail. But we're not doing square roots. Remember, square roots meant two. You need pairs. These are nth roots. Third roots, which we call cubic. Fourth roots, fifth roots, sixth roots, and so on. A little refresher. Square root of 0.81. Nothing too crazy right there. 81 is a square number. What times what gives you 81? 9. Because 0.9 times 0.9 is 0.81. Simple enough. Now, do you know what the square root of 324 is? I don't, off the top of my head. I know what it is now because I've already done it. But I couldn't think of it. So you know what I did? I broke it down. Now this negative is on the outside, so it affects nothing. It just stays on the outside when we're done. But let's take 324. Now I know I can divide it by 3. I know I can divide it by 2. Wait, can I divide it by 3? Yeah, 3 plus 2 is 5. 5 plus 4 is 9. I can actually divide it by 9. So maybe I'll do that. Remember that little trick. If you add the numbers up and the numbers are divisible by 9, the whole number is divisible by 9. So let's see. 324 divided by 9 is 36. Now you might recognize right away, those are both square numbers. Oh. So some of you might think, well, what's the square root of 9? 3. What's the square root of 36? 6. You would be correct. I just want to write down this as an example. Negatives on the outside. Inside we've got a pair of 3s and a pair of 6s. Well, guess what? It's radical jail. These 3s and these 6s get to escape. But remember, it's a square root. We assume 2. Pairs can escape, but only one comes out. The other one stays behind. No, the other one is gone. Nobody stays behind. 6 times 6 is 36. Square root of 36 is 6. If you have a pair of 6s, 1 6 comes out. The other one is gone. So we have 3 times 6, which is negative 18. It was 18. 18 times 18 is 324. Forgot. But you don't have to remember those things because you guys know my ability with numbers is not always good. My ability with thinking through things is pretty good. But my ability with this day-to-day numbers, it's not the best. Not the best. Oh my goodness. We have jumped from radical jail of a square root to a sixth root. A sixth root. You know what that means. You know how hard it is to escape? How many sets, I can't say pairs because 2's not enough. How many sets does it need to escape? You need 6 2's to escape, or 6 3's, or 6 4's, or 6 something to escape. Well, I said 2 because I know the answer is 2. Because I know that this is true. And I know it a lot because you just multiply by 2. 2, 4, 8, 16, 32, 64. It's something that I know. I also know binary numbers pretty well, base 2s. So I know that one. What if you didn't know that? What if you didn't know that? Well, let's just say you didn't know that 2 squared is 64. I'm sorry, 2 to the 6 was 64. Well, you break 64 up. You might recognize it as 8 times 8. Okay? How does the 8 break up? Remember, there's only 2 8s. Not enough. We need 6. Well, let's say 2 times 4. Okay, now I have 2 2's and 2 4's. But I need 6 to escape. Well, the 2's are broken down, but what about the 4's? Broken down as far as it'll go. 2, 2, 2, 2, 2, 2, which means I've got 6 of them. 1, 2, 3, 4, 5, 6. And all 6, it takes all 6 to escape. But how many get out? Just 1. Just 1. Another way to think about it is this. We had 2 to the 6th power. That's how many 2's we have. Oops, let me fix that. I don't like that 6 right there. So you see how these are the same. It means I have 6 2's. And I need 6 2's to escape because it's a 6th root. So these are inverses of each other. A 6th power and a 6th root are inverses. They will cancel each other out. So you're left with 2. So I want you to keep that in mind, because even though radical jail is a great way to think about it, it's really not the most effective way. Here's a 5th root of this fraction. Oh, fractions, negatives, 5th roots, all together. Great. Well, let's deal with the negative first. First of all, think about the negative. It's a negative. When you say you can't take the square root of a negative number, well, you're right. You can't take the square root of a negative number because that's 2. But this is an odd one, 5. So think of the inverse to the 5th power. If you took a negative times a negative times a negative times a negative times a negative, would you have a positive or a negative answer? These 2 would cancel. These 2 would cancel. You would have a negative answer. So if you've got a negative under an odd root, you're fine. Your answer will be negative. So I'm not going to worry about that one because we're okay. Now let's take the 1024. Now some of my computer people out there might recognize 1024 as a binary number. Well, let's just take the 1024 and break it up. Now I could break it up into 2 times something, but there's something bigger we can multiply that by. Let's see. Can you take 1024 and divide it by... I was going to try 8. Okay, there we go. 8 times 128. That's good. What's 8? Whoops. I'm going to try to always keep them in order. 2 and 4. All right, I'm going to break all these down as far as they'll go. Now I've got 3 2's already. I'm looking for 5 to escape. I think 2 is a nice safe bet. What about 128? What can we break that down into? We can divide it by 2. Let's just divide it by 2. We're left with 64. Wait a minute. I don't like to do too much work. What was 64? Do you remember? 64 broke down into 2 to the 6th power. Let's just borrow that idea. So 64 is really 2 to the 6th power. Okay. Now how many 2's do we have altogether? There's a negative. Now, do you want to write down all 10 of them? 2 times 2 times 2 times 2 times 2. No. Let's put them in groups of 5. So would you agree that when all said and done here, I've got 2 to the 10th power, 6, 7, 8, 9, 10. I have 2 to the 10th power. Well, wouldn't that be the same as this? Two to the 5th times 2 to the 5th is 2 to the 10th. Remember, you add the exponents. Okay. Hold that thought. Let's jump now to our 243. What can we break that down into? I know 9 because 2 plus 4 is 6, 6 plus 3 is 9. So I know it goes in 9 times. Now, of course, you know me. I don't remember exactly what that is. That is 27. 27. That breaks down. 3 times 9. Now, we don't have 5 of anything yet, so if I can still break it down, I'll break it down. And sure enough, when I break these down, what do I end up with? 1, 2, 3, 4. I have 3 I'm sorry, I have 5 3s, 3 to the 5th power. So I'm not going to write all 5 of them out. I'm just going to write it like this. Now I'm going to actually fix this root so it's correct. Whoops. Well, we'll just do it green then. How about that? All right, so what's the 5th root of this? Okay, so the negative stays. If I have 2 to the 5th power, remember it takes 5 to escape. How many come out? 1. I get another 2 to the 5th power. It takes 5 to come out. 1. I've got 3 to the 5th power. Well, it takes all 5 to get out. And how many will get out? Just 1. There is my answer. So if you take 4 to the 5th power, 4 times 4 times 4 times 4 times 4, it's 1024. If you take 3, 3 times 3 times 3 times 3 times 3, it's 243. So the 5th root of negative 1024 over 243 is negative 4/3. And that is really the whole thing. That's all we're doing is we're breaking these things up into groups of 5. And we're going to throw some exponents in there, but it's the same principle. Now 243, geez, we just did 243, didn't we? So I'm going to rewrite this. What is, under the 5th root again. So 243 is really what? 3 to the 5th power. Now x to the 10. We'll just leave it as x to the 10 because it's already broken up. And let's use our magical abilities to determine nth roots. Here we go. We've got 5 3s. Takes 5 to escape. How many escape? 1. Okay. We have 10 x's. It's like we write x 10 times. Okay. If I wrote out x 10 times and broke them into 5s, how many 5s do I have? Well, I've got 2. Now, if you think about a little pattern you see here, hopefully you're picking up on it. Whatever my exponent is, 5 divided by 5 is 1. 10 divided by 5 is 2. This is my answer. Okay. Did it work with square roots the same way? It did. It's been a while, but it did.